Hello everybody, this is Ramit Diman and you are watching Ramit Engineering Works. So today we just interface this type of relay with this type of microcontroller. The microcontroller that we are using, it's 8089 S52, it's 8-bit microcontroller. We have used this DIP package we are making on this perf board. So first we do on the perf board and then final PCB is making. We use this type of two power supplies, separate power supplies. For one is for driving the relay and the another one is for driving the microcontroller. We have used this type of programmer to program this microcontroller from my laptop. As we see in this video, here is the reset circuitry. When something is stuck in this microcontroller, we have to press the reset button from here. Here the resistance are used. This is the pull-up resistor for this relay, and the another relay is for safety purpose for gate to the BC547 as a switch transistor we have used for driving the relay. Here is the reset circuitry that is connected with the pin number 9. Here is the clock frequency. We have used the crystal oscillator of 11.0 something megahertz, and these are the 33 picofarad filter capacitors that is grounded up with the ground line of this microcontroller. So in this arrangement we have used this type of oscilloscope to measure the duty cycle of this microcontroller, and we have to drive the AC load. We have used the AC load as a 100-watt bulb. It's fluorescent bulb that we have used, which is driven by this relay. We have to control the on-off pulses with this type of microcontroller. So right now we just program the microcontroller first. As the microcontroller is programmed, it runs every time what we programmed in it. So let's get start this video. We have these type of arrangements. We have used this laptop for programming and the oscilloscope for measurements and see what's inside goes on in this microcontroller. So let's start this video right now. So now we have to send the code, blinky code, on this microcontroller. Here is the microcontroller. We have to send the code, and here is the written code as you can see on my screen. Here you can see the code. We have used the Prog ISP software to program. Here we just load the flash file and send the blink code. Here we have to program and press the auto button. As you can see, the programmer is in yellow LED glows, and here you can see the bulb is blinking as I turned off the lights. As you can see, the light speed, we have the delay of around 20 milliseconds. Here if we have to increase the delay, we just need to replace it with the 2 and then 4 is used. So first, as you can see, if I press the 2 and replace 4 with the 2, then there is the 10 milliseconds delay, and we upload the same program. Here we have to program. You can see the delay is changed. Yes, the off time is changed. If we fast this, we have to again change the second row to so right now we just program the microcontroller, and we have to check the voltage on the output pin as I connect the positive to the positive of this LED, blinking LED. So here you can see it's 0.64 volts when it's active. As you can see, it reaches 0.70 volts when it blinks. So we have used the pull-up resistance for this. Now we have to check the crystal oscillator's frequency. We just use this we have connected to the crystal, and here you can see the crystal oscillator's frequency. As the crystal shows, it's 11.062 megahertz. Here you can see it's as I move closer to my oscilloscope, here you can see the actual frequency. We have to measure the all parameters. Here you can see the frequency is, here you can see the frequency, it's 11.069 megahertz. It's oscillator's frequency that the main microcontroller is on working. So here you can see we have connected our probes to the microcontroller's pin to the oscilloscope, and here you can see the frequency wave of this oscillator. You can see the frequency at 11.06 megahertz. So our crystal is working perfectly. And here which frequency the LED blinks, and here is the code for this. We have to connect our probes, the positive probe to our microcontroller LED, and now we have to press the auto button. So here we have the final output. Whenever this LED glows, the peak wave is get there. We have to turn off the lights. So if you see the LED blink right here, When the LED blinks, there is the peak waveform rises. Here you can see when this LED glows. As I move towards server side of vision, so when this LED glows, there is this cycle changeover. So now we turn on the lights first, and then in the live situations we have to put and change the value of delay. We just change the one parameter. 50% duty cycle. We have used this type of program. It's 40,000 for on time and off time, and we have to load to the microcontroller. And here you can see the LED is blinking, and the wave you can see here. Here is the off time, here is the on time of this bulb. Right there you can see. So right now we check the duty cycle. Here you can see it's the duty cycle of 50% of average. It's changing from 40% to 55%. That is the excellent value for the swinging program. So now we interface the relay with, as you can see, then when the LED blinks, here you can see the internal structure of this circuit is like this. Working of this structure is this. As this LED glows, as this pinout glows, there is the waveform with respect to this. Here is the off time of this LED, here is the on time. Now we have to interface with the AC load like this. Now we disconnect the oscilloscope from the circuit, and the programmer out, the laptop is out, microcontroller is programmed for the 50% duty cycle. Now we connect the power supply of 5 volts. There is the 5 volts for the microcontroller. The another 5 volts is for the relay. Here everything is gone fine. Now we have to connect the AC load with the AC voltage. Here we have connected the, here you can see the load is connected with this circuit. As we program this microcontroller for the 50% duty cycle, and the wave comes out of the 240 volts 5 amps to this, as this fluorescent lamp. It's 100-watt lamps. There is any load of this kind, AC load we have produced in this. So in the way, when the sine wave is produced, the 50% of the time the relay is off, and the 50% of the time the relay is getting on. For this circuit do the same thing for lot of hours, lot of days, because the program is saved in this microcontroller. This do the same thing every time. Here the load changes with respect to your needs, as your needs change, because your application is of programming your angle grinder or any cutters or any machinery. You have to send the code to me and send your applications. I program it for you. Like same procedure follows out. As we have produced the 5 volts from microcontroller, as I switch off the 5 volts to the microcontroller, then there is no program right now. In this condition, the relay stops in the on position. We have to stuck off, and then we have to off and then on. Here's the on function of this circuit. As I off the power of this relay, then the bulb is got switched off. As you can see, there's no working, and there's no supply to this electromechanical relay, and there's no supply to this coil, and this doesn't work right now. But if I on the supply, the relay is again working. Here's the reset circuit. When something is stuck in the particular way in the on-off state, then there is nothing. We have to reset the circuitry, we have to reset the machinery, we have to press the reset button like that, and the program restart from first position. As you can see, when it goes off, I press the button, then it turns on. If we want to run the program from first line, we have to press again. So if you have similar kind of works, you can contact my numbers anytime. We have this is the particular hour of my electronics and communication lab. So if you are interested in this type of components and this type of crafts and these type of things, embedded system programming, you can contact my numbers. We are fulfill your requirements for the embedded system and programming systems. We have successfully programmed this type of things. Here we have to run AC loads with the DC microcontrollers. These are perfectly isolated from the AC supply. You have to press the button for 5 volt, and you can run the AC appliances of much higher voltages. You can contact for this type of similar works. Thank you very much. This is Ramit Diman from Ramit Engineering Works. Now there is no need of this programmer, so we cut off this programmer right now and use for programming purposes only. The main function is of this microcontroller that runs the circuit right now, and this has the capability to run the same circuit for 25 years, because its programming life is of 25 years. As soon as the operational voltage is same to this 5 volts.